Okay, so I think it's almost everyone is back. And so I think, so there'll now be a presentation on adjusting for scale use, heterogeneity, and self-reported well-being. So whoever is presenting, you have until 2:30. Great.
Great. Thank you. And thank you for inviting us to this conference. It's been really interesting. I think this is a super important set of issues, and it's been great to hear everyone's thoughts on these topics. What I'm going to be presenting is joint work with Kristen Cooper, who unfortunately couldn't come to the conference because she's been teaching intensively the last few days. Ori Heffetz, who's here, Miles Kimball, I think, who's also here right now, and Jinan Zhao, a PhD student at Colorado, who can't be here. Let's see. So, I hardly need to motivate this topic for this audience, but very briefly, there's a very large and growing literature on self-reported well-being and comparing it across groups and across time and countries. There are at least two major methodological questions one might be interested in. One is what's measured by these kinds of responses, and much of the work that my team and I have been doing over the last few years is focused on that question. For this paper, we're focused instead on the question which has been a major theme of this conference, which is about the extent to which we can compare responses across people, and to the extent that they're not directly comparable, can we adjust the responses in some way to make them comparable? So this is, the idea that my 70 on a 0 to 100 scale might be your 80, and if so, that's potentially a major confound for a lot of SWB research. So I'm going to talk briefly about the data we collected, and then and I want to highlight at the outset that it's really just pilot data at this point. We collected it's 500 individuals from MTurk, so we're currently planning a much larger data collection, but I think it'll be useful throughout the talk to see some of the patterns that we're looking at in the current data that we have. Then I'll spend most of the talk on the theory and relating what our approach to existing approaches to scale use adjustment. And then I'll talk about just one application, again, using our very preliminary pilot data, and also a very preliminary econometric approach. So this is all very much work in progress. So in our pilot data, we collected responses to 33 self-reported well-being questions. This is one of them, which is our version of a life satisfaction question. How satisfied, thinking about the past year, how would you rate how satisfied you are with your life? Notice that the response scale here is from 0 to 100, and there's a label. There are labels on the response scale. We think that this kind of 0 to 100 scale helps reduce some of the issues that have come up with earlier in the conference with the more limited response scales. For example, there's less need to assume that there's some distribution on a latent scale because you're observing more of the points, but that's not something I'm going to focus on in this talk. Okay, so the question is how satisfied you are with your life, and then the respondent moves the slider, and then in this example to 63, and the person is told what they've chosen, and then they confirm it and they move on. So as I said, we have 33 questions, 33 questions like this. We have a happiness question, a ladder question, but also questions about things like your sense of purpose in life and your sense of physical safety and security. So we ask about a lot of different aspects of well-being in addition to these kinds of overall evaluation questions, which are typically used as utility proxies. You know, in addition to these questions, we also have a set of questions that we call calibration questions, and these are going to be key to our approach to adjusting for scale use. So here's one of them. We ask the respondent, how dark is this circle? And the response scale here is identical to the response scale for the SWB questions, and that's important. And so this is one. We have 18 of these calibration questions in total. I'll show you some of them. Here there are three of the 18 are related to circle darkness. There's 3 different levels of circle darkness. And then we have another set of 3 questions related to how curved is this line, with low, again, a low, medium, and high. Then we have one which is how big by land area is this region, where we just made up a country and have, you know, show in kind of low, medium, large areas of regions within a country. So that's 9 of our 18 questions. I won't talk about the other 9 because they're a little more complicated. But the basic idea is that we try to choose questions, these calibration questions, where we design them in such a way that we think that the true answers in some sense are essentially the same across people, up to maybe differences in perception between people. So the main thing we're getting in differences across people is the way that they're using the response scale. Okay, so now I may talk about the theory. And I'm going to begin by kind of a brief history of work in this area in economics. So one of the earliest papers is by Andrew Oswald, and he talks about he defines this idea of the reporting function and gives an example of height. So he imagines that for different heights, different people would give different subjective ratings that correspond to the same objective height. And he talks about the psychophysics approach. Psychophysics is an area of where people are asked, you know, how heavy is some object, and they give a rating of that, or they're asked how loud is some sound, and people give different ratings. And so this is analogous, and you could then estimate each individual's reporting function, the mapping from the objective level to the subjective rating. And then you could imagine inverting that function to get back an objective height from any given person's subjective rating. So Oswald has this discussion in the context of saying that the SWB literature at the time was inferring that people have diminishing marginal utility of wealth because you observe, or diminishing marginal utility of income, because it seems to be a concave mapping between income and happiness. But his point was that could be concavity of the reporting function, and we don't really know which it is. So it's premature to attribute it to diminishing marginal utility of income. He outlined this psychophysics approach, but then argued that you couldn't really apply it in the happiness context. And the reason was that, you know, you can do it for height because we have objective measures of height, but it's not like it's going to be the same function for height and other areas. In fact, in psychophysics, there are different subjective mappings across different domains, like how heavy something is or how loud a noise is. So you'd have to do this mapping for objective happiness, and there is no current way to measure it. Now, you could imagine that there's some kind of technological progress. Maybe we can measure, you know, brain activation, and that could be a measure of objective happiness. But you know, I would add to Oswald's concerns that if by happiness what we really care about is well-being, you know, even something like the brain activation may not give us an objective measure of that. So we may just be stuck with never being able to actually implement this approach. So another approach, or the other main approach in the economics literature, is anchoring vignettes. So this was pioneered in the political science literature by King et al., and then applied to disability in the workplace by Kapteyn, Smith, and Van Soth in a 2007 paper that was published in the AER. And then they applied it also to life satisfaction and happiness in 2009. I don't think that paper was ever actually published. So the idea, and I'll just use King et al.'s original example of political efficacy, which is basically how able you feel to affect political events. The idea is that you obtain ratings, you give a little scenario about different people, like Allison's life situation is this, and then you ask person one and person two to rate Allison's political efficacy, and also give ratings for other vignettes, Jane and Moses in this example. And then you ask them to rate themselves. So, for example, person one rates themselves an 88 here, person two rates themselves a 25. And we can't make sense of the individual numbers that people are giving, but because they've rated the vignettes, we now know their ranking of themselves relative to where they are in the vignettes. So it gives us an ordinal scale. It's less ambitious than the psychophysics approach, which was trying to get back this cardinal underlying true state. Here we're just getting an ordinal ranking. So now, as I mentioned, Kapteyn, Smith, and Van Soth tried to apply this idea to life satisfaction and happiness. And there have been a lot of concerns that have been raised over the years about that particular application. So for example, in the scenarios, you only can, it's a few sentences of description of somebody. Different people might make different assumptions about things that weren't mentioned in the vignette, and maybe that's correlated with the way they do the ratings. That would create problems. People might just have a hard time imagining themselves in someone else's situation, and that could create biases in the way they rate the vignettes. More fundamentally, if this is supposed to be a utility proxy and the vignettes are describing different aspects of well-being in a person's life, but people have different ways of aggregating across different domains in order to come up with an overall sense of well-being, then there may just be no common ranking across people. I mean, it's crucial in this approach, and you can see an example that person one and person two have to agree on the rankings of the vignettes, and there may just be no fundamental agreement on the ranking if people have different preferences. So it's a bit of an aside, actually, for the main point of my talk, but I do think those concerns about the vignette approach could be minimized. So specifically, I think a way to do it, and the way we would advocate doing it, is to apply the approach not to the utility proxies like life satisfaction or happiness, but instead to the more fundamental things that people care about in their lives, like having a sense of purpose and being physically safe. And there we think that people's rankings of vignettes are likely, that's going to minimize these. I think we minimize all the concerns, but for example, the different ranking concerns, I think it helps with, because I think people are likely to agree on much more on the relative ranking of vignettes related to those things. And then you can elicit individuals' ordinal preferences over the aspects of well-being, as we've talked about in some of our other work. And then I think you could then use import some of the important work that's been done in welfare economics about how to do interpersonal comparisons in a philosophically grounded way. Okay, so as I said, that's a bit of an aside to what we're up to here. I want to focus on what I think is the main concern with the vignette approach. Actually, I think remarkably has not gotten much attention in the literature, and that is that in its pure form, the kind of theoretically justified form that I just laid out here, all you're getting is an ordinal ranking. So you don't actually have units for the kinds of applications that we want to do, like running happiness regressions. Now, the way it's actually done in practice is a parametric version, like you assume ordered probit or something, but then your units are just coming from nowhere. They're just like arbitrary units that are coming out of some assumption about the distribution of a latent variable that really doesn't have any justification. So the key thing about our approach that I want to highlight is we're going to assume that any two individuals reporting functions are a linear transformation of each other. So I think that's what's going to allow us to make some progress. as I'll show you, that's motivated by our evidence. And it's going to provide a natural scale for applications. And it's going to allow us to build the theory entirely on observables. In fact, we don't even need to posit the existence of something like the true underlying level of the variable. Okay, so here's our approach. I'm starting again with this height example. Sorry, but instead of height, we're going to be doing something like the darkness of a circle. And then we're going to obtain ratings for these calibration questions, like the darkness of a circle. And then we're going to calculate the mean across the different individuals' ratings for each of the different levels of the calibration question, and identify the translation, what we call the translation function from each person's own ratings, the mean ratings. And so effectively, we're using the mean ratings in the sample as the units for analysis. So this is going to give us an interval scale rather than an ordinal scale, and that's exactly what's needed for applications. Basically all the applications in the subjective well-being literature, like running regressions, doing factor analysis, comparing levels across countries or time. Okay, so I said this was, this linearity assumption is obviously very strong. I said it had an empirical justification. So let me show you that. So this is from our pilot data. Here I'm showing you for our 18 calibration questions. There's 18 points in this figure. On the x-axis is the mean response to that calibration question on the 0 to 100 scale, and on the y-axis is respondent number one's response. So what you see is, and then I have a kind of local linear regression. I mean, it looks kind of linear. It's noisy for one person, but it doesn't look like a crazy departure from linearity. Here's person 2 against the mean. Here's person 3. Here's person 4. So I think they tell a story. You can't, it's hard to tell from these figures because they're noisy. But when we do a careful statistical test, what we can conclude is that there is some departure from linearity, but quantitatively it seems to be very small on average across people. Now, when we aggregate up, actually, we get rid of a lot of the noise, and you see much better how close to linear it is. So here, for example, on the x-axis is the respondents with above median or above $60,000 income, and the y-axis is people below $60,000 of income. And what I'm showing you now, each point is again a calibration, one of the 18 calibration questions. And so I'm graphing the means, and the red line here is the regression line, the black line is the identity line. Now you see, it's quite close to linear. Correlation is 0.99, but you see that there are some differences in the scale use that that people with the lower income use a little bit less of the scale. So that's something like what we're going to call a difference in the stretcher parameter for people with lower income. On the next, here's male versus non-male. Again, very close to linear, but not the same use of the scale. Here's not living with children versus people who are living with at least one child. Here, there's no difference in the stretcher, but it seems like there's kind of a shift, a vertical shift, with people who don't live with children give lower answers on average to the calibration questions. Here's employed versus not fully employed. So again and again, across the different demographic splits, you see very, very close to linear relationships. Okay, so as I said, we're then going to assume linearity and then use the mean ratings as the units for applications. And the linearity implies that it actually doesn't matter. Using the mean is arbitrary. We could have picked any person. We would have gotten the same answers in all applications up to just an arbitrary shift of affine transformation. And so, all the rankings across people and all regression coefficient rankings and all of that's going to be the same. And that unanimity, then, we, if we get the same answer if we use my scale or your scale, that provides a justification for use of this scale. Okay, so something else we're going to do, and again, this is not central, but we're going to focus on what we call general scale use. This builds on a literature in psychology on response styles that some people tend to use more of scales than other people, and some people tend to avoid the bottom of a scale, other people tend to avoid the top of a scale. So there's a literature on this. It tends to be, it's not, it tends to be about kind of categorizing people into these groups and then showing that it's correlated with other things and with demographics. It's actually quite important, and here's it from our data, an illustration of that. What I'm showing you now on the x-axis is the mean across, but now each point is a respondent. There's 500 of these points. The x-axis here is their mean response to the 18 calibration questions, and the y-axis is the mean response to the 33 SWB questions. And you can see that there's a correlation of about 0.5 or 0.55 between these. A lot of the variance across these SWB questions is being captured by just these general scale use differences that are captured by the way people rate the darkness of circles or the curviness of lines. Here's the same graph where now what I'm showing on the x-axis is the standard deviation for a person in their response to the 18 calibration questions, and the y-axis is the standard deviation in the answers to the 33 SWB questions. And here the correlation is even stronger. It's like 0.6, 0.666. So this is saying that the amount of the scale that people are using is very strongly correlated across the SWB questions and their answers to questions like the darkness of circles. And this, both the mean and the standard deviation in these calibration ratings are related to demographics. So here's just regressions of the mean and standard deviation on demographics. And something I'm just going to highlight here, because it'll come back to it in the application, is like if you look at age squared, you get a U shape for the mean in the response to the these darkness of circle type calibration questions, just like you see in the with happiness or life satisfaction measures. Okay, so we focused on general scale use, and that's going to allow us to use these calibration questions that aren't specifically about happiness and life satisfaction, rather than vignettes that are specific to those questions. But our approach would apply just as well to the scale use specific vignettes. And that's something, but it's kind of more natural given our framework to focus first on general scale use. Okay, so here's the model. We have the response. This is for question J. This is the way the kind of level response that a person gives. The shifter parameter. This is the stretcher. This is the mean response in the sample to question J. And I'm just going to show you what I mean by general scale use.
Dan, you have a minute or two left. Would you mind wrapping up? Thank you.
Sure. Okay, so let me skip ahead then to the application. So I'm just going to give one application here, and again, this is very preliminary, but I'm going to show you a life satisfaction regression. Life satisfaction is on the left-hand side. This is a regression on demographics. So you see the standard U shape with age, increasing with income, other standard patterns here. And now here's what happens after we apply a simple version of our scale use correction. Actually the income coefficient goes up, but the U shape with age goes away. Why does the U shape with age go away? I mean, you kind of saw it before in the regressions, but I'll show you visually. Here's a graph of age versus the life satisfaction ratings. Here's a graph of the mean calibration ratings against age. They also show this U shape. And then this is them on the same graph. And when you effectively take the difference, which is a version of the scale use adjustment, a simple version of the scale use adjustment, then you see that it's a much flatter relationship. Okay, I'll stop there.